Let us solve another good numerical on work energy power, important for your JEE main and your NEET examination. Now this time the force is constant but the displacement is a variable. Now if you look at the statement of the problem, the distance x, distance is symbolized as x. The distance x moved by a body of mass 0.5 kg. A mass is given under the action of a force, and the force varies with time such that the distance x is given as 3t square plus 4t plus 5, where x is in meter and t is in seconds. What is the work done by the force in the first 3 seconds? In the first 3 seconds means starting from t is equal to 0 to t is equal to 3 seconds. Just by looking at the problem, how can you say that the force is constant? Look, the displacement is given, x is 3t square plus 4t plus 5. If you differentiate it once, you will get velocity. So the power of t will be reduced by 1, this t will go, this t will remain. Then if you differentiate again, you will get acceleration. So the power of t will be completely vanished. Means acceleration will be constant. So only knowledge required is a simple differentiation. So since x is given, your velocity will be since x is variable, so to find velocity we have to differentiate it. So your velocity, let it be v, will be dx over dt, that is differentiation of 3t square plus 4t plus 5 with respect to dt, and it's made up of 3 different terms. So that will be equal to derivative of 3t square with respect to dt plus derivative of 4t with respect to dt plus derivative of a constant, that is 5 with respect to dt. So what do you get? A simple differentiation. 3 comes here being a constant, derivative of t square with respect to dt plus 4 comes here. Now derivative of t with respect to dt plus, since 5 is a constant and derivative of a constant is 0. Now again that reduces to, I hope you know differentiation, 2 comes here. So 2 times its power will be reduced by 1. So t to the power 2 minus 1, that is 1 plus 4, dt over dt is 1. So that is equal to 6t plus 4. So the velocity is a time dependent. So to find acceleration, we have to again differentiate it. Therefore the acceleration, the symbol is a, will be dv over dt. And this is your velocity by differentiating the displacement once with respect to time. So if you differentiate this with respect to time, you will get acceleration 6t plus 4 over dt, that is equal to differentiation of 6t with respect to dt plus differentiation of 4 with respect to dt. So your acceleration comes out to be 6 comes out, dt over dt is 1, let me write, and differentiation of 4 is a constant is 0, so acceleration is 6. So we get acceleration is equal to 6 meter per second square. And I hope you know the meaning of acceleration. 6 meter per second square means you can write it as 6 meter per second over second, means the speed will increase by 6 meter per second in every second. That is the meaning. That is the meaning of acceleration. Means If it started from rest with u is equal to 0, after 1 second the velocity will increase by 6 meter per second. From 0 to it will increase by 6, so the velocity will be 6 meter per second after 1 second. After second the velocity will again increase by 6, so 6 plus 6, that will be 12 meter per second. Again after 1 second the velocity will increase from its previous value by 6, so 12 plus 6, that is equal to 18 meter per second. That is the meaning of acceleration, right? So acceleration is constant. Mass is given as 0.5 kg, right? Therefore the force will be equal to mass times acceleration. Mass is given as 0.5 times 6, that is equal to 5 over 10 times 6. So that comes out to be 3 Newton. So your force is equal to 3 Newton. So 3 is a constant. So what is the conclusion? If the displacement vector or the distance vector is expressed in t and the maximum power of t is equal to 2, then you differentiate it twice, the t will not be there, means acceleration will be constant, and therefore the force is constant. Now then what we have to do to find the work done? Therefore the work done will be, since it has asked to find the work done in the first 3 seconds, means there is a limit of integration from t is equal to 0 to t is equal to 3. So your w will be equal to integration of f dx. Because the displacement is given in x, so I have to write f dx. Now here is the trick. Now here f is not given in terms of x. So I have to change that. Force is equal to mass into acceleration. This is your dx. Now then how to rearrange that? Your acceleration is equal to same thing as dv by dt, and dx remains as a dx. Now if you write this dt in the denominator below dx, then this becomes integration of m dv dx over dt. So what happens? This becomes velocity. So integration of m v, this becomes dx over dt is v dv, right? Now m is a constant, can be taken out because the value is given. So m integration of v dv. Now v we have already found out in terms of t, 60 plus 4. Then this becomes, your v is equal to 60 plus 4, its integration with respect to dv. Now let me switch over to the next page, then it becomes easier. W is equal to m integration of m times integration of 60 plus 4, 60 plus 4 with respect to dv, with respect to, did I make a mistake here? Change in velocity, v dv, not sorry, and your v is 60 plus 4, where did I make a mistake? I made a mistake here. I have to. Oh, I made a mistake, so I'll do it once again, not right now. I made a mistake here. Your A can be written as 6m dx. So, m dt. Or dx can be written as v dt. You have to make a change here. Sorry. Let me rewrite it for you. Sorry, I made a mistake. So your w is equal to, so your w is equal to integration of, w is equal to integration of f dx, f dx, and f is equal to your mass times acceleration, or you can write it this as integration of f v dx. This is the trick that you have to play. Velocity times dx. That is equal to integration of f. Dx is a distance, so that will be velocity into time. Let's write v dt, right? Now you substitute integration of f. F will be your mass times acceleration. F is given as 3. F is given as 3. V we have found out as 60 plus 4. 60 plus 4 times dt. Now it's okay. Sorry, I made a mistake. So integration of 18t plus 12 with respect to dt in the first 3 seconds. So that is the limit. So that comes out to be integration of 18t dt from 0 to 3 plus integration of 12 dt from 0 to 3. 18 comes here, integration of t dt plus 12 comes here, integration of dt from 0 to 3. So this is equal to t square over 2, its value from 0 to 3, 0 to 3 plus 12, integration of dt is t, its value from 0 to 3. So I put 3 here, 3 square, 9 over 2 minus, I put 0 here, plus I put 3 here, 3 minus 0, so that is equal to 81 plus 36, that is equal to 7, that is equal to 11. So this is your work done, this many joules. So the work done in the first 3 seconds is this much. I made a mistake here. Don't look at this. So force is constant. Acceleration is equal to 6. The velocity was obtained by differentiating into ones, and the velocity came out to be 60 plus 4, means the velocity is time dependent. And therefore the work done is equal to f dx, and since dx is a displacement, so this can be written as velocity into time, small displacement in time, small time dt, so that will be v dt. Now put the value of v. F is 3, dt remains as this. So here is the trick. You have to express this dx in terms of velocity and time, so that you get within the integration a function in the form of t and dt. Therefore, it will be simpler to integrate. So that is all about. Thank you.